Have you heard about jargons like microservices, virtual machines, or containers that can potentially enable business? Have you ever got confused listening to the complexity of these technologies? If yes, this video is for you. We will talk about a business story and try to understand how these technologies can help. Let us assume that I own a small business and I decided to build an e-commerce website to sell my products. My team decided to build basic features like inventory to store basic inventory information about my products, catalog to list all the products so that customers can get the required information about the products, a basket for the customer to select and add the products that they would like to purchase, and finally checkout to actually purchase the product. My IT team wrote the code and included all features in one single application and tested it. We ensured that a potential customer can log into the application, review, select products, and then check out without any issues. We decided to build the production infrastructure for deploying the e-commerce application that we developed. First, procured computer hardware, installed server operating system, configured applications like databases, web servers, published the application online so that potential customer can visit the website for buying products. Many customers started visiting the website and started ordering the products. Great job! During the holiday season, we started seeing a spike in demand for our products. In fact, that's a good thing. However, my IT team started reporting some performance issues, and few customers started complaining that they are unable to order products using the portal. Looked like there is some capacity issue. To solve this problem, we procured more server hardware, installed operating systems on it, installed applications, and configured high-performance cluster so that customers can perform online ordering even if one of the systems in the cluster fails. This worked perfectly. After the holiday season, we realized that the number of transactions reduced by over 50% on our website, as our product demand was seasonal. Many of the new servers we procured were no longer needed, but we will need the higher capacity during next peak season. Is there a way to reduce the operations cost of maintaining many servers while we are not using them? Yes, of course. We decided to move our application to virtual machines in the cloud. Let us have a look at the cloud environment. Cloud vendor provides hardware and hypervisor. Hypervisor is a piece of software that can manage the underlying hardware. On top of the hypervisor, we could build any number of virtual machines and allocate hardware resources appropriately based on our business requirement. We could pay for the infrastructure based on our actual consumption. So we built multiple virtual machines, installed operating systems, databases, web servers and applications, and configured another high-performance cluster over there. We could increase capacity during peak seasons by adding more virtual machines. We could stop virtual machines after the season, thus saving a lot of money. No capital expense for buying server hardware, reduced operational cost of maintaining additional servers during off-season. It was also easy to move the virtual machines to a different hypervisor for fault tolerance. This looked like a great solution for us. The business started growing and we wanted to add more functionality to our e-commerce application, like loyalty programs and daily promotions. We estimated the budget and timeline needed to deliver these new features. There was a lot of work involved as we need to integrate new features with existing applications, test them, and then release them to production. Any code change can affect the functionality and performance of the whole application. We identified that it may take months to release the features we needed, but our business needs these features in production, ideally in weeks, not months. How can we build new features and modify existing functionalities faster in future? We realized that it is important to find a solution for this problem to grow our business. We decided to split the monolithic application that we built to a microservice architecture. That is, create separate applications for loyalty, inventory, catalog, promotion, basket, and checkout. They should be able to talk to each other using APIs, but should be able to run independently for the most part. For example, catalog application should run independently without much dependencies with any other micro applications that we build. If catalog application wants to check the inventory, then there should be a way to query the inventory application using API and get the required information. Let us assume that we need to modify checkout. All we need to do is to modify the code of one application, that is checkout, test it and release to production. The time to develop and test dependencies reduced a lot, and thus reduce the release time to days instead of months. Another advantage is that we can now run each microservices in different virtual machines and scale up based on demand. For example, if we need to increase the capacity of checkout, we can increase it alone by adding new virtual machines only for checkout application. This gave us the opportunity to manage computing resources efficiently and thus reduce operations cost further. Now you may have another question. Why should we build different virtual machines for each microservice application to work? This includes building and maintaining operating systems for each of the new virtual machines. Can we avoid that and then reduce the hardware capacity utilization further? Good question. The answer is yes. Container technologies can be used just to do that. It is possible to run application along with all the configuration dependencies in a container, and multiple containers can run in a single host operating system. Let us look at how container technology works. Here is a hardware layer. Then here is the host operating system. We need to configure container runtime on top of the host operating system. The runtime can host multiple containers on top of it. Containers will have just the required applications, dependencies, and configurations running on it. For example, we can run the applications like catalog in one container and inventory in another container on the same host operating system. We can also scale application capacity as per the business need. For example, we can create more containers for checkout application if there is a need to increase capacity. As containers do not need full operating system running on it, it utilizes less hardware resources. and thus reduce the operating expense further. We can also move container to different host operating systems easily. Now you must be wondering how to manage these containers, because there can be hundreds of containers for the application in our scenario. How to monitor container health, how to ensure fault tolerance. Not a problem. There are container orchestration technologies that can be used for managing containers. However, the complexity of management increases as we move from having server hardware in our data center to virtual machines to containers. For example, managing security can be complex as the attack surface area increases. Someone has to get access to the data center to access the hardware, or compromise the operating system or applications running on the standalone server to take control of the system. The attack surface area is higher in virtual machine scenario because there is a probability of hypervisor getting compromised. All the operating systems running on the top of hypervisor can be compromised if the hypervisor has critical vulnerabilities that can be exploited. The attack surface area is even higher in container scenario, as we are adding more components like host operating system, container runtime, and container itself. If the host operating system is compromised, then all the containers can be at risk as they are all sharing the same host operating system kernel. There is also risk of container runtime or even containers getting compromised. So, the decision to move to technologies like containers may help business to make changes faster. However, it also comes with additional responsibility of managing complex systems and securing them using appropriate security controls. I hope you understood how microservices, virtual machines, or container technologies can enable the business. Thank you.